the AWS Developers Podcast. We're in Las Vegas. We're talking about swimming today, data and swimming. Stay tuned. Good morning, good afternoon. Thank you for listening to the AWS Developers Podcast. We're recording this from the Wynn Casino and Hotel and Conference at Las Vegas. And I have the pleasure to welcome Annie Nave. You're a part of AWS Professional Services. You're senior data scientist. And recently you work with the Australian Olympic swimming team. Wow.
Yes.
So you had a session with them at reInvent. How did the session went?
The session went really well. I feel so lucky in my role in professional services to get to work with different organizations such as swimming. And it's been such a pleasure to work with Swimming Australia.
So tell me, what is the relationship between Swimming Australia and AWS?
So we've been working together since 2018, actually, collaborating on different technology projects. And what we found is that the organizations fit so well together because high-performance sports in general, they move really quickly. So it needs a company like AWS, which can move at the speed that high-performance swimming is moving at, right? Like this cadence, as opposed to traditionally where they get technology from is through universities, and postdocs, but this moves much slower than how we move at AWS. So it's been awesome. It's been a great part.
And I'm not at all into sport at high level. So what a sport team, what are the IT needs of a sport team? Why? What's their business case?
What's their business? So maybe I'll jump into to the most recent work and what we presented our great session on. So maybe I'll start by setting some context on Swimming Australia. So swimming is Australia's most medal-winning sport. We are so proud of our swimming team. They're like our golden treasure, the swimming team. And if you watched the Paris Olympics earlier this year, you would have seen the Australian swim team won 18 medals. It's 18 just in swimming. And 7 of those medals were gold.
That's a lot of gold medals. Yeah.
And this is our toughest rivals at the Olympics for the Australian swim team are the US swim team, who are also really strong. And they won 8 gold medals.
Okay, it's just one difference.
So it's just one difference. And if you look back over the last few Olympics, we've been closing this medal gap with the US.
So next year, or in 4 years, the goal is to have the same number of medals or even more than the US.
Exactly. And Swimming Australia is really well positioned because of the way that they're using technology and the way that they're viewing technology as an asset to get the best out of their athletes.
That's the part I don't understand. And that's why you are here to explain how a high-level sportive team is using technology to improve their performance.
Yeah. So let me get into that. So we know, Swimming Australia knows that they're at the cutting edge of the way they're using technology. That's how they know it's a competitive advantage because they have this system called Sparta 2, which is an optical analysis solution, which means it processes video footage, and they process video footage of their athletes in competition races. So it's specifically for competitions.
So it's to analyze the behavior, the movement of the athlete during the competition.
So they'll set up a camera, and this was work they did before I came on to help them. They set up a camera in these competition races, wherever they are in the world, set up a camera in the back stand, and then they film the swimmers doing the race. And then post-race, they'll process that video footage. So they'll take the film off of the camera, put it through the system. This system uses computer vision to pick out things like, it can track the athletes, so it can pick up times and distances. What was their time for the first half of their lap versus the second half of their lap? It can detect their strokes. So we can look at things like what was the stroke rate? Like how did that...
The moving in the water.
The moving in the water. How did that change from the first half to the second half? Things like that. And we know the Sparta 2 system, it has helped them so much. And they can see, Jess from Swimming Australia, when she explains this, it's really nice. They're all looking at the other nations.
Yes, they also compare with the other teams because they have the footage not only for their athletes, for all the athletes from the
so they can
the race or whatever we call it in
exactly. So they can start to create a profile of the other international swimmers as well. So the Sparta 2 system, it's been working for them really well, optical analysis in competition races. But they've always had this dream, and they're calling it the F1 garage. And it's about bringing technology to the training pool. So just like F1 cars have their garage where they take the car in and like in real time, they're having all these analytics. They want the same thing for the training pool. And the reason why the training pool is so important is because that's where the athletes are spending most of their time, right? Like 95% of the time, the swimmers are training and the races are just the end results, right? So they're like, if we can get technology in the training pool,
you can get earlier information, insights about their performance.
Exactly. And then the races, that's just the end. That's the end result of using technology to hone the skills in the training pool.
So they can move the existing system, the Strava, Sparta 2, to the training.
Yeah. So great question. So there's a few challenges around that. So that's why this is exactly where this work fits in. So the first challenge is that everything happens in retrospect with Sparta 2, meaning that the race completes and then the data is analyzed and then we get these performance metrics.
How long after?
In the order of hours. Which doesn't work for training because then the athlete has lost the feel. Like if we want to tell them, well, that lap you did 10 minutes into the session in the morning, they can't remember. It loses. They're training all the time.
So it has to be not real time, but close, within minutes after they finish a lap.
Exactly. Or we almost want, like, as they're swimming the lap, we've noticed that they're swimming it well. By the time they get to the end, their head comes out of the water. We want the coach to have that data to be able to say, you performed that really well. Keep doing that. Or on the flip side, maybe you started too fast. Let's try starting a bit slower, conserving your energy, finishing stronger, things like that.
And so they decide to redesign or to recreate a new system.
So we need to recreate a new system, which uses some of the key aspects of Sparta 2, but make it real time so that we can have immediate athlete feedback with this data and immediate coaching, better like data-driven coaching decisions. That's one thing. The other thing is it's more challenging in the training pool than a competition pool because it's much more chaotic. If you think in races, it's a defined structure, right? 100-meter freestyle, everyone's in their lane. In training sessions,
they can stop in the middle of a lane or in the middle of a lap and restart or do something else or just practice the start.
Exactly. So a training session is made up of multiple drills, right? It's not just swim. There'll be a drill. This drill might be looking at the technique of turning on the wall.
And I think I read somewhere, it was in the blog post, and I'll put the link to the blog post in the notes of this podcast episode, of course, that you had a geographical challenge as well. I mean, the team is in different cities in Australia. It's a big country, so not all the athletes are training in the same pool every day. So you have to distribute the technology.
Definitely. We need it to be able to scale, which means we don't want to rely so much on expensive hardware. Right, because that's not going to be able to scale across different pool locations.
Yeah, you cannot install TV camera, professional camera in every pool.
In every pool, exactly. And something else on the pool location, another challenge with the training pool is that the bandwidth, the internet connection of these training facilities, it's not good. Swimming Australia trains in public pool locations.
They don't have fiber.
Yeah, so it's not equipped. It's not equipped to be like this high tech space. So this is another challenge that we run in when we want to use the speed and the flexibility and scalability of the cloud. How can we still access this in these training pool environments where the internet connection is limited?
So what was the solution, the high level? Maybe we can start from the high level architecture and then drill down into the individual components.
Yeah, definitely. So the system we call Training Insights. So this is this new performance analysis system for the training pool. It works by, similar to Sparta 2, we set up a camera in the backstands of the training pool. So it has bird's eye coverage over the entire pool. And then it's streaming videos of the athletes training.
So it's camera above the swimming pool?
Correct.
Because I remember watching the Olympics this summer. We had the TV has also camera under the water.
Yeah,
Is it useful for training as well?
Similar to what we discussed before, is this now we're getting into like bespoke equipment, right? These underwater cameras, and then they need to move as well. We won't have a good view of the entire pool from under.
Position the camera at strategic place underwater.
Yeah, so it's a bit more challenging.
Okay, so you start with the...
We have above, so we see the whole pool, only one camera. So the athletes are not limited to a particular lane or anything like that. Yep.
And then...
Yep, and then we stream when there's also an end user application, and this is what the coach or performance support staff is looking at, and that's how they're getting the data stream.
Mm-hmm. And it's a web app, a mobile app, or something.
Yep, a web app.
A web app.
A web app. Yep, hosted on AWS Panorama. Yep.
Okay.
And we so as a training drill is starting, the coach will press a start button, and this is what initiates the processing of the camera frames through our training insights system, right? So the camera is always set up there. It's always kind of always streaming, but only when we press start, we start processing it.
Mm-hmm.
When we process it, we send it to an edge device. And so we have a hybrid architecture here, which is...
Some of the processing is made at the edge. So it means in the swimming pool, not in the pool, but in the venue, in the building.
Yeah.
And so that you can, the advantage of that, I guess, is that you can only stream relevant data to the cloud and not the full video stream.
Exactly. Because the problem, what we're trying to do is process really high resolution video frames, and it has to be high resolution because we're running computer vision models, right? We don't want to reduce the quality here. High resolution video footage, we need to process it up into the cloud, stream it over the internet in unreliable internet. So instead we decouple it and we do all of this processing of the high resolution video footage at the edge. So we don't have to stream very high resolution video footage through the cloud.
So what is the system, the hybrid system you installed there? I guess it's not a Raspberry Pi. It's a bit more sophisticated.
Yeah, we use AWS Panorama.
So Panorama, if I remember well, I wrote an article about that a couple of years ago. It's an appliance that you can receive camera feed, local camera feed.
Correct.
It's a very robust size designed for industrial environments. And then you can run a bit of compute there. And that device is connected to the cloud and can send a result of whatever is running there.
Yep, correct.
So that's
fully managed device and software development kit as well to help you write the models which will deploy onto it. Yep, correct. So the machine learning pipeline, which calculates our performance metrics. So the camera frame stream to Panorama. On Panorama is a machine learning pipeline.
Okay.
And this machine learning pipeline is what transforms the camera frames into data insights.
Each image is transforming to data.
Correct.
And so you apply the computer vision on the Panorama.
Correct.
How do you upload a model to a Panorama? It's like a Docker container that you send, and it's a bit more complicated than that.
It's part of the AWS Panorama service.
Okay.
So there's best practice. So in the cloud, you develop your models. We develop models on SageMaker, and then you can deploy them onto Panorama easily.
Panorama. Yeah. What's the output of that model on the device?
Yeah, great question.
Technically, it's what, a JSON file? Or?
Exactly. Yeah, it's just a text file, just a JSON file. So then that text file we can send up to the cloud because it's extremely lightweight. It's just text.
So the video image are not crossing, are not sent over the internet to AWS. So you can use whatever bandwidth you have at the facility to send only JSON files.
Exactly. And then so we just send these text files with the key data inputs of what the machine learning model has picked up in the images. And then that gets sent up to the cloud. We send it up with Amazon SQS.
So from Panorama directly to a queue where the message will be processed later. At business level, what is in the JSON file? You said timing. What are the business meaning of the data that you're sending if it's not confidential, of course?
Yeah, no, not confidential. So the machine learning pipeline, I can talk... Oh, let me talk about the text file first. Maybe we can...
Then we can continue.
Yeah.
What happens to that text file later? No, I'm curious.
Yeah. So we look at the tracks of the swimmers. So the first challenge is to detect where are the swimmers, right? Like just given an image, where are the swimmers?
So in a frame
in the frame. Yep. Then we have to connect them across multiple frames to actually track them, right? Because we need to be looking at. We don't want to be jumping between swimmers. This is how this.
Yes, there might be multiple swimmer together. So
lane.
the system must analyze one at a time.
The system
or lane, a specific lane. At a time?
The system looks like it's specific lanes.
Okay.
Yes, correct. So we detect the swimmer, we track the swimmer, and then we also have so let me say, so with those two bits we can then get distances, speeds, because we know the frames per second of the camera, so that helps us convert distances to times. And then we have a different computer vision model which detects when the swimmer is taking a stroke. So that gives us all the stroke rate, number of strokes, distance per stroke. And then we also have a different machine learning model which detects when they've touched the wall. And this is specifically for a swimming turn. So we want to calculate the different aspects of a turn. How long did it take them to get into the wall? How long did it take them to get out?
How did you train this model?
We trained it on SageMaker.
But you need, it's supervised training, so you need a lot of data to label them.
We need a lot of data, yeah. Swimming Australia does actually have a lot of label data from competitions. So it's a great question. So in competitions, they have a touchpad at the end of the wall. So when you touch the wall, it automatically uploads. So we could use that data as our labeled data set to then train our own model to understand what does it look like when the athlete touches.
Do you have an idea of the quantity of data, the years of history of data that was required to train this model? Is it? I try to get an idea. Is it like terabytes of video image from 10 years of swimming, or is it much less than that?
It's less. It wasn't a huge model, was it? And let's say the key point to the training data was to make sure that we had lots of different angles of the pool, lots of different lights. So a challenge with computer vision with pool is the pool glare. You get a lot of pool glare.
The reflection from the light from the water?
Exactly. And that comes out differently depending on the training facility. So so we really needed to make sure we had a broad span of pools that we were training the data on, so the images were noisy enough so that our model was robust and it could be used in lots of different pool locations, like we said, swimming.
And did you train a model from scratch, or did you use a pre-existing off-the-shelf computer vision model that was fine-tuned, or if it's not the correct vocabulary, specifically for that use case?
No, this one we trained from scratch.
From scratch on SageMaker, where you can ingest the data, clean the data, run your pipelines, evaluate the models, rank them.
Yeah.
And then once you have a good candidate for production, that's the one that you push to the Panorama device.
Yes, exactly.
And I guess it's automatic. There's some kind of continuous integration chain to push the model to Panorama, or is it like a one-off operation, manual operation?
Yeah, there's a machine learning pipeline around that. Yep. And maybe something unique about using edge device is that you want to test your model in the edge device environment before you actually go ahead and deploy it. So we had an environment which was simulating what the Panorama device environment looks like, the same setup. So we actually run our models in this custom environment.
So it's a simulator of the Panorama device. It's provided by the Panorama team, or it's something that was developed for that project?
No, it's already provided.
It's out from. Okay.
Yeah.
So at the end we have a JSON with all the data that you are at the end. At the end, we are still in the venue right now, in the facility of the swimming pool. What happens to that JSON? It's pushed over the internet to a queue. And what's on the other side of the queue?
Yep, and then it's picked up by an application on AWS App Runner in the cloud.
So containers, Docker.
Yep, and it's picked up, processed a little bit further, but not really, just kind of massaging the data a bit. So we get it in the format which is most useful for coaches. And then the coaches see it on their app as it's happening. So the idea here is that as something is just complete, so let's talk about turns. We were really focusing on turns because Swimming Australia said this was critical for them. This is like a skill that the swimmers really need to hone in the training pool, how to do that turn on the wall as quickly as possible. So we have computer vision triggers. So as soon as a swimmer has completed a turn, we detect that. So we detect, someone's starting a turn. We can see that they're moving in the right direction, and they're 15 meters away or 5 meters away from the wall. So they've started a turn. Then we start to follow them, and then we say, okay, now they've just finished a turn. That's another trigger. We use our wall touch machine learning model, which we've discussed, to also look where exactly did they touch the wall. So we have a perfect breakdown of this is how long it took them to get into the wall, this is how long it took them to turn around, that's how long it took them to take out. And then a coach then, as we hit this computer vision trigger that the turn is complete, the coach then sees this data.
How long after? It's a matter of seconds?
Yeah, near real time. Wow. And then the coach, and our idea, we're still testing this, but the idea here is the coach sees this data and then straight away can have, like, if that turn was a bit slow compared to what the other swimmers are doing. And we're talking like fractions of a second, I guess. You can't pick this up with a stopwatch. So it's really revolutionizing for swimming. You can't pick it. It's so hard. What they do at the moment is have support staff just looking. They'll stand at the end of the pool, look down, and try and capture with a stopwatch when they've touched the wall. But it's
it's not in the same competition.
Exactly. You can't capture fractions of a second. So the coach can see, the swimmer is losing a fraction of a second. Like 0.02 seconds. So then they can have this conversation with the swimmer and say, like, let's concentrate on your turns. I think this is an area we can improve. They can improve that. And you'll see if you watch the Olympics, swimming races are often won or lost by fractions of a second. And it's so hard to tune the skill if you don't have technology that can operate at this level of precision, because it's too hard for us to catch it with stopwatches. So it's really exciting to be able to use this technology to really get the best out of the athletes in this way and help them to win gold medals.
How the coach is visualizing the data? Is it raw data, like they have like a table saying this business metric, this value, or they ask for graphs or comparison and things like that? I guess there is a team that work on the end user application, on the front end application as well.
Yeah. The front end application is still quite basic at the moment, so it is just a table of data that gets populated as the swimmers are training. And maybe an important thing to note here, so everything is automatic, so it can be as quickly as possible. So we do have, after a training drill has completed, there's then the option to edit this data, right? Like in case it's picked up something incorrectly, we can edit that because then we upload the data for long-term storage. So we really...
That's my next question. Do you archive these data? Can we run an analysis or comparison later on?
Exactly. Yeah. So we have this manual review step. So we get all the data just raw, automatic, as quickly as possible. Then when the training drill is complete, then we have a little bit of time, right? So we can edit, we can change anything if we need, upload it to Amazon S3 for long-term storage. And then this in itself, it unlocks a lot of opportunities, right? So there's the real-time training pool component, but by having access to training data over years, that's like masses of data. It's really exciting for swimming.
Are you bringing the same system to the competition to compare the system at the training with the system at the competition? Or is there a gap with two different systems, one for competition and one for training?
We're trying to leverage as much as possible from Sparta 2, which is this competition system. So like purposefully, it helps us develop faster, but also because from the business perspective, we want these performance data metrics to be as comparable as possible.
Yeah,
right.
If you bring the new system to the competition, then you cannot compare with the historical data.
Yeah. So we might have some like technology bias in how we're now picking up the athletes swimming compared to in training. And we want to have everything we need to get them, everything we need for competition in training as it is, so we can tune those skills, right? Like as we need to see them in competition. So we want comparable data metrics. So yeah, we use a lot of those same models in Sparta 2 competition, but we make them real time rather than post process. We make them more robust to the chaos of training pool. And we have this hybrid edge and cloud architecture so that we can operate in limited bandwidth. So this is how we've had to adapt what they have in competition.
In between competition and training. Do you have any type of feedback loop to continue to improve the models and to generate the next version of the model? How is it managed in the project?
Yeah, it's a good question. We have nothing set up at the moment, but for sure, that would be a natural next step.
Especially now that they are acquiring a lot of data, maybe it will be easier to tune the model or to train the model.
Yes.
You have more data, more video footage.
Yeah.
Do you capture some video frames as well for that purpose? And there are still a couple of video frames that are sent back to the cloud carrier?
Great question. So we want exactly like what you're picking up. We want the video footage. We want to store that long term. One, so that we can, and especially important in testing this new system, we can validate. Otherwise, we say, oh, we've predicted that they touched the wall at this time. But if we don't have the video footage, we have no way to build this trust with the models. But then also for long term, for retraining, for training new capabilities, having access to data is everything, right? That's the differentiator. So we definitely want this video footage. So we do have a separate stream up to the cloud using Kinesis video streams, which is streaming the video. But the important thing here is that we've decoupled it from the performance metrics so that if the internet drops or something, it's not going to affect our data metrics. So we have the separate stream, which is kind of in its own time, because this doesn't have to be real time.
It can be after the training, after the hours.
Exactly. In its own time, it's streaming up. It's also, we have a parameter where the quality can reduce a little bit if it's really struggling on the internet, right? Because it doesn't matter too much. So we have that as a separate stream.
What is the service that ingests the video frames on our side? It's Kinesis, I guess. Yeah. Kinesis. There is a version of capability in Kinesis dedicated to video frames. No, it's Kinesis video something.
Video streams. Yeah.
Video stream. So it's made for that to receive a stream of video. Can we imagine later some kind of constraint goal metric, like if I want to improve the performance by 0.1 second, I have to gain at the turn, or I have to start a bit faster, like some kind of predictive of where the athletes can gain some time.
Yeah. Great. So kind of two things you're picking up here. One is the skills component of swimming. So this is the bits you just said, like the starts, the turns, the finishes. It's not just swimming. So there
is a technique to turn.
There's techniques, right. There's skills. So these skills if we can identify them, then we can improve these particular skills. And even when it's fractions of a second, which it is.
Yeah, at Olympic level or worldwide competition level, it's on the details.
Yeah, exactly. So we want to be able to identify these points that we can improve. At the moment, we only calculate the performance metrics. We don't have another intelligence system sitting on top of that to then say, okay, given all these performance metrics, this is what you should do, right? So we still have the coach doing that processing.
That's the importance of the coach.
That's the coach, and the coach has a lot of experience, and there's obviously a lot of science to coaching, but there's also a little bit of an art to coaching, right? They have a lot of experience, they have a lot of intuition. So at the moment, we're not in that space at all. It's just this is the metrics, and we've worked with coaches to figure out what metrics are most meaningful. So like we just give you the data metrics, you use your coaching experience to interpret this. And you figure out what are the areas for improvement. But I definitely think an exciting next step would to have some kind of agent or some other kind of intelligent system which can help the coaches to say, no, this is the data metrics, and this is where I think the athlete can improve, or maybe this kind of training drill would be particularly useful for this athlete because we've seen this and this and this and this over the last few training sessions.
What are the challenges you had to implement that project? The things that were more complex than originally anticipated? And the consequences, what did you learn?
Yeah, great question. I think one challenge was we were working under extreme timeframes. So we were trying to move as quickly as possible. So we were thinking from Swimming Australia, how can we help you the most by setting up some kind of foundation that then you can build upon, right? Like they had all these, Swimming Australia had these dreams of like, this is what we want the training pool to look like. But we had to take these dreams and take a first step, right? And take a step in a way that we really are enabling them to then grow. It can grow on its own. So we really focused on setting up this like backbone architecture, hybrid,
as quickly as possible,
setting up this real-time machine learning pipeline. But what is so nice about this now is that we have this foundation. So it enables Swimming Australia to build. So now we can build all sorts of computer vision models, right, to calculate lots of different training metrics, and it just has to slot in to this machine learning pipeline and architecture that we've already fit as the foundation. So we've set up this really strong foundation that now.
So time to market was the main challenge in this project. Build something quickly so that they can start to use
build something quickly. Yeah.
Is that something that you discover that you didn't anticipate? Something that you learn while working on that project?
Oh, I learned so much.
Yeah, every day we
every day we learn so much about swimming, so much about their high performance mindset. They talk about performance by design. You know, like there's a lot of smarts that goes into these. Yeah, so it's really amazing to be involved.
So you touch the subject a bit because now you have the foundation and we talk about what's possible, but what's the future for that project? Do you have any idea how they are going to continue to build on it or to improve it, maybe new functionalities that are planned or ready to be delivered, again without touching any secrets?
Yeah. So one advantage of having an optical analysis solution, so we haven't spoken about this much, but we aren't using any wearables or any sensors or anything like that. All of the data insights are extracted from the camera, which is actually extremely powerful because now we can scale it. Like I said before, now we just build different computer vision models. We don't have to go out and buy hardware for all the different data metrics that we need, which isn't going to scale at all. So definitely what's next is to build in more functionality. So we've concentrated on turns. And then we have the aspects of free swimming, such as distances, times, velocities, and stroke mechanics. But we really want to look at now other aspects of swimming, such as like kicks, detecting their kicks. This is an important thing that coaches will look at and a metric that they'll tune. The breathing as well. How often are they taking a breath?
So the camera has a definition high enough to detect the breathing moment.
Yep.
Because it's not only when the water comes out of the head comes out of the water. It's a specific moment during that sequence.
Yeah.
Oh, okay.
The breathing, or at least like to start with, we can see like the moment that they've turned the most for the breath. So kicks, breathing, breakouts as well. So whenever they go underwater, like in the start or at a turn, then they break out from the water. So this is an important metric that the coaches would like to see. And then we can even go look at starts. We could measure their reaction to a start gun at the start of a race to get that. Again, fractions of a second, but it makes a difference in races. So definitely what's next, build out these capabilities, get it in front of coaches and start to get the benefits for the LA Olympics 2028.
Yes, that's the next one.
Yeah.
While you were talking, I was thinking this is quite cost-effective system as well because Panorama appliance, it's a bit too expensive for me as a personal user, but for an enterprise, for a company, it's not super expensive. The camera, it's out of the shelf hardware that you can find quite easily.
Yeah.
SQS, App Runner, it's not services that are consuming or charging a lot per month. So it's a very cost-effective solution that you built.
Yep, and very, very robust as well. So another challenge with wearables or sensors is that athletes might not like it. It affects the feel, and they don't wear wearables in competitions. It's not allowed. So they don't really want to be training with something that they're not going to be having in competition. So there's challenges there, and coaches might not like things that are in the water interfering. But because all we have is a camera, in the back. No one needs to notice it. It's really robust, cost-effective, scalable, and flexible then also because we hook into the cloud so we can use all of the flexibility of the cloud.
And I think my last question will be a stupid one, but the swimming pool are reserved for the training of the athlete, or you might have other person in the swimming pool as well. Why I'm asking the question is about the handling of personal information and the image. I know that Australia and Europe, we are very sensitive about that.
Yeah.
Is it a challenge for this project?
Absolutely. Yeah. Not a silly question at all.
Okay.
It's a, yeah.
No, but maybe it's a closed space where only athletes are trained.
Yeah. So they're public training pools, and during training sessions, sometimes they will not have the whole pool. They will only be using a few pool lanes. So we can set up, before the training session starts, we can set up to only look at a few lanes. Well, not the camera, but only process data for a few lanes. So we're not processing data on the public. But we still, for PII, to make sure we comply with the Australian video PII protection laws, this is why it's important that our camera is at the back with this bird's eye view, because then we can't make out any faces. And so we don't have to worry about PII.
So it was a subject during
a huge subject
project as well. I'm glad I asked a question.
Yeah. Maybe when you asked about challenges before, I could have brought that up. Yeah, that it's a challenge.
Yeah, to be compliant with the law. That's a fascinating conversation. How the technology is influencing sport at high level, and how we manage to capture data with computer vision to give coaches data to better train the athlete and to help them to bridge the gap. So 4 years, Los Angeles, at least the same number of medals than the US, or even more gold medals.
And then after LA is Brisbane, which is to Australia.
Oh, so next Olympics after LA.
Yeah, which is quite nice because we're in Las Vegas now, not too far from LA. And then the next Olympics are home ground.
We'll close the loop. Thank you, Annie Nave, from AWS Professional Services, Senior Data Scientist. Thank you for sharing the insights of that project with the community, because you were talking with Jess at reInvent and now in the podcast. So thank you very much. Thank you for having listened to this episode until the end. And now go build.